In continuation to the previous topic, that is conduction in polymers, we saw one of its type is making inherently conducting polymers. So we'll learn more about it here. So we'll start with the key discovery. The key discovery for conducting polymers was in the year 1973 when they identified polymer polysulfur nitride SNX to act like a metal. That is, its conductivity at room temperature was around 10 power 3 ohm centimeter per the whole per minus 1, which was almost comparable to that of metal. And another interesting thing, if you remember what I mentioned in the previous slide about the superconducting property, this particular material showed superconducting property below the critical temperature of 0.3 K. So it's quite interesting. So this made people to think more and more about the material. But this material also had some drawbacks which really prevented it from going to commercial aspect. That is, this material has it has an explosive nature. So what gave the metallic character to SNX? People started thinking on it. So this intrinsic property was due to the presence of one unpaired electron in each unit of Sn. So you had Sn suffix x units. So just imagine how many unpaired electrons would be present in the material. And this was the reason for the material to behave like a conducting material. It was totally different from that of other polymeric materials. Whereas when you take other kind of polymeric materials, normally the electrons will be paired. You don't see any unpaired electrons. And that is the reason why the other materials behave as dielectric polymers. So this was quite interesting and people started moving on. Okay, slowly the scientists started finding out that, okay, when you expose this material SNX to some oxidizing agents, again the conductivity varied by an order. It was improved actually. So this made people think more and more, and there was a breakthrough. That is, redox chemistry was taken as the key. Fine. Then polyacetylene, one of the polymers, was taken and it was subjected to oxidizing and reducing agents. So what they found was it had an intrinsic conductivity which was very low, 10 power minus 5 ohm centimeter, the whole power minus 1. But when it was exposed to oxidizing or reducing agents, it could give around 10 power 3 ohm centimeter, the whole power minus 1. Fine, this could be called as p-type or n-type doping as far as solid state physics is concerned. If you have to link the chemistry and physics part here, I would say exposing it to oxidizing reducing agents means you're making it pure n-type doped material. So another important criteria you will have to understand here is how it is able to be oxidized or reduced, how fast it is. That really makes an important point here. So if you take an example of polyacetylene, it has the bondings, both pi bond as well as a sigma bond. So this pi character is something which can be easily removed or added to the polymeric chain, to the polymeric ion. I mean the other way, other one, sigma bond is primarily for holding the polymer together. It is the backbone. So in some cases, you can have oxidation or reduction by electrochemical means also. So this includes polypyrrole, polythiophene, etc. Coming to polyacetylene again, here you can see that the pi bond can be shifted. It can keep moving from one to another, whereas the sigma is static as it is. People thought, okay, initially this was the reason. This pi bond was one which was helping, and this was the reason that you could really make the material p-type or n-type as we call in physics terms. So initially the conductivity increase observed upon doping organic polymers was thought to result from the formation of unfilled electronic bands. But slowly this was also not true. People found that even in polymers like polyacetylene, polyparaphenylene, polypyrrole, they also showed this property of conductivity, but it does not seem to be associated with the unpaired electrons. So there is nothing to do with the unpaired electrons which can be removed easily, added easily. Rather, they found something called as spinless charge carriers. So what are these spinless charge carriers? Fine, we'll be looking at it slowly in the next slide. So there we will talk about concept of polarons, bipolarons with some examples. By the time you will come to understand what are spinless charge carriers and what makes these polymers as conducting polymers. Hope you had a nice topic today. That's all. Thank you.